Okay, as promised, algebra people, we are going to also solve systems by using elimination. Now, I actually really like elimination. I think it's the fastest, right? Last time we learned substitution, saying that if I have a $20 bill, that's equal to 2 tens, right? Or if I have a $20 bill, it's also equal to 4 fives. But can I add them? Can I add them? Or if I have two $20 bills, will that equal to 2 tens and 4 fives? Right? Well, of course it does, because $40 still equals $40, right? Always. $40 equals $40. So how can we apply that to actual mathematics? It's all about that balance, right? It's all about being equal. So elimination says this. If I know these two equations are equal, I can add them together. Just like we added two $20 bills, and it equal to adding 2 tens and 4 fives. Even though they look different, if I know they're a system, that I can add them together. And let's look at the magic that happens this is when it gets mathematical. Right here, when we add these together, 5x plus x is 6x. But negative 2y and positive 2y eliminate. This is why this is called solving by elimination. Because then it goes by so quickly, right? It goes by so quickly. I can just divide then and solve and get the x. Once I have the x, I substitute it in and get negative 3, 8 for this equation, right? I found the x, I substituted it in, and then I solve for the y, and I get that negative 3, 8. Okay. You try this. Add these two together and see what eliminates. It's mathemagical. Pause the video here and then check your answers. Let's see how you did. Yeah, that 3x eliminates. Then you end up with 3y because you have to add it together. Equals 12. Divide and you get 4. Then you substitute that 4 back into either one of the equations. I chose the first one. And you get that x is negative 2. Okay, that was adding. Guess what? You can also subtract. Yeah. Well, what do we mean by that? Well, I can see that in the middle there, that, gosh, 4y and 4y, if only that one was a negative 4y. Well, we can make it be 1. We just multiply the whole equation by negative 1, right? So I distribute a negative 1 to that whole equation. So I did here, here, and here, right? Now when I add up the equation, it eliminated the 4y. It's mathematical. And I can solve for the x, substitute in, and solve for the y. Yep, there's my one shared solution. You try. Try this one, pause the video, and check your work. Let's see how you did. Is this what you got? Did you eliminate the 3y by multiplying the second equation right here by a negative? And get x is 4, and then plug it back in and get 4, 1. Okay, so now we know that we can eliminate if they're opposite and the same value, right? If they're opposite and the same value. So can't I change any equation to be any number I want as long as I multiply the whole thing by it? If only 2x and negative x were the same value, well, why not multiply that second equation by 2? We can do that. Yep, that's completely math legal. I do that by first keeping the first one the same, multiplying the second one by 2. Everything in the equation though, everything. Now, when I add, it eliminates. Boop, it's magic. And I solve for the y, plug it back in, and solve for the x. To get my one shared solution. Go ahead and try this again. And check your work. Multiplying the second equation by 3, so I can eliminate that x value. Now, of course, I could have eliminated the y. You can do either. It doesn't matter. You'll get the same answer. Plug it in and solve and get 2, 0. Hopefully, you're starting to realize that some of your equations could have been solved so much faster. Now, what about this one? This looks complicated. Nothing is common here. So how do I deal with this? Well, I need to pick whatever I want to eliminate. I chose to pick the y value, because the common multiple with the x value would be 35, but the common multiple with the y value is just 24. So I just need to first decide what I want to eliminate, so I can eliminate anything. I decided to eliminate the y's. So I'm multiplying the top by 2 and the bottom by a -3, because I need to get them to be the opposite sign. So I first multiply the top by 2, and I multiply the bottom by -3. Now I can see my y values eliminate. It's mathematical. And then after you eliminate, it's so quick to solve, right? It's like 2 steps. Then I just substitute back in to solve for my y value. Easy peasy, lemon squeezy. Let's get our homework done. And now we have 3 ways to solve for systems of equations.